Hello and welcome back to the second video on quadratic equations. Today we're going to talk about functions. So why do we need to know about functions? Let me explain with an example. Let's say you have never seen a game of basketball before, and someone tells you that in basketball, it is really important to know how to dribble. You'll be very puzzled thinking that, hey, isn't basketball just about baskets and balls? What has dribbling got to do with this? Now, to someone who knows basketball, you will know that basketball is an important tool, although it's not the main objective of the game. Now, likewise, functions, right, is an important tool, right, that allows us to understand many other mathematical concepts. So let's get to know functions a little bit better today. And here are the notes. So right off the bat, I just want to address the elephant in the room, and that is functions and equations are not the same. I know in schools, this part, functions, gets glossed over very easily, either because students don't pay attention, they think that they are the same thing, equations and functions, or the teachers teach this part really fast. So very quickly, I just want to introduce you to the idea of functions and how to write them, how to read them. Okay, so first of all, let's learn how to write and read functions. So what we have here is, say, if I have a function called f, usually I'll have to write it with a bracket, okay? And in between the brackets, I'm going to put in my input here. Okay, and usually the input is x. But there are also times when our input can be, say, time, t. We can have this as well. And a lot of times students will read this as f bracket x. But the correct way to read this is actually f of x. And then, of course, this will be f of t. You don't really have to use f all the time. Other good letters for functions would be g of x, h of x, u of x, and v of x. Okay? Next, let's look at what do functions do. At a very basic level, you can just think of functions as machines. Right? You have your function f over here. What it does, it accepts an input and it gives you an output. Okay? And let's look at that with a more concrete example, where, say, if I have a machine, I put an orange in and I get orange juice out. So I can say this is an orange juice function, orange juice machine. Okay? Now, but of course, we in mathematics deal with numbers, not fruits and oranges. So what we do is, for example, if I have a machine that adds 1, it just adds 1. That's what it does. If I put in x equals to 1, my input is 1. What happens is that the machine will add 1 to what I put in. So that's 1 plus 1. And what you get out is 2. Yes? Rather simple. Okay? Then, of course, we are not just interested in one set of input and output. We want to look at multiple inputs and outputs all at once. So here's an example. If I put in to the same machine, the plus 1 machine, I put in x equals to 1, 2, and 3. I get outputs 2, 3, and 4, respectively. Now, this can get messy very fast. If I have 10 inputs, I'm going to run out of space to put these things. So what we do is we put them in a table, like this, where the first row is the input and the second row is the output. All right? And I know most of you are thinking about this right now. Hey, don't equations do the same thing? I don't have to use functions for this, and you are absolutely right. Okay? Instead of having a function, I can write an equation and say that y, right, is equals to whatever the input is, I'm going to add 1 to it. Yeah? And you get exactly the same thing as functions. And here is where I will tell you the difference between functions and equations. Number one, functions have a constraint to them, and that is they can only have one output. Right? They can only have one output for every input. Yeah? If I put in an orange, I'll get orange juice. Yes? Now, what about equations? Equations are allowed to have multiple outputs for every input. Okay? So again, right, for a function, you put in orange, you get a cup of orange juice. That's fine, right? We like that. But if you have an orange and you put it into a machine, and this machine actually peels the oranges first, so you get an orange skin, and then after that, it gives you the orange juice. So you get two things, orange juice and orange skin. Now this is not a function, right? This is not a function. What we want is only one output for every input, okay? And definitely you'll be thinking, wow, functions are so silly. Why do we have to learn about functions? Why do you say it is an important tool to learn mathematical concepts? Right. Let me try and convince you, right, with two benefits why you should use functions. Okay. So here's an example, which I'm sure you're very familiar with. Right, if I give you this, you should be able to suspect that this is simultaneous equations. And of course, when you have simultaneous equations, first thing you want to do is name your equations, different numbers, 1 and 2. Why do we have to name them? Do you know why? That is because if I didn't name them 1 and 2, and someone says substitute x equals to 5 into y, the first question will be, which y are you talking about? Are you talking about this y or this y? Right? And that's why you have to name that equation 1 and 2. But if you use functions, you skip that altogether, because then there's no ambiguity which one you're talking about. So someone will say, substitute x equals to 5 into f. And you know straight away we're talking about the green one. Yes? The problem with equations is that they use the same letter for every output of different machines. Okay? In functions, you use different names. So we have a benefit for using functions. Now, the second thing is in simultaneous equations, right? Say you want to substitute x equals to 5 into equation 1. Yeah. So before you actually do the substitution, you have to write a statement to tell people that, hey, this is what I'm doing. Right? In functions, it is much, much simpler because remember, what goes into the bracket is your input. And if I want to input x equals to 5, I just have to write f of 5, right? F of 5, and I can go about my working straight away. Yeah, and that is the second benefit of using functions. So that brings me to the end of this video. I hope I have clearly explained to you the difference between a function and an equation, and also what are the benefits of using functions. So thank you for watching. I hope to catch you in the next video where we talk about roots. So until then, catch you on the flip-flop.